we will see specific analysis techniques, a small review, because we are entering into problems. Suppose if you say, as I said, it is called specific because each technique is valid for some circuits, not valid for all circuits. That's why it is this, I have named it as specific analysis techniques. Under this, theorems come. Source transformation come. Impedance transformation come. Source transformation means voltage source converted into current source. This is star to delta conversion. Here you have 10 theorems. Out of the 10 theorems, main theorems are: first one, Thevenin's; second one, Norton's theorem; third one, Millman's theorem; fourth one, duality of Millman; fifth one is maximum power transfer theorem. All these 5 theorems are together. In fact, all are based on Thevenin's. For example, that's why the most important criteria is Thevenin's. And if suppose this is Thevenin's, okay, this is called V Thevenin's and R Thevenin's. V Thevenin's is also called VOC, ZOC. This is not a circuit, that's an equivalent of a circuit. What is all this? What is the one condition in all this? In all these circuits, 5, we have one important condition, that is, circuit is fixed and load is variable. Please remember, that's a very important. Circuit is fixed here, load is variable. And that fixed circuit is converted into voltage source, open circuit voltage source, open circuit impedance. Suppose this is called AB, and that is equal to ISC or Norton's. Because it's current source, it is parallel. Same ZOC there. This is called same R Thevenin's here. This can be called as short circuit current. Therefore, VOC followed by ZOC, ISC followed by ZOC. Suppose you want to see the equivalency here, call it as this. And if you want to compare what is VOC from here, that is simply the voltage across AB is simply VOC. Why? Because the current in this branch is 0. When the current is 0, what happens is this becomes neglected, this comes over here. Where here? If you see the same VAB, the voltage across AB, this current coming over here, this is ZOC into ISC. Therefore, your impedance is again same. Whatever R Thevenin's here, same also here. So, if we say first point comparison of circuit, second point voltage, third point impedance. The only comparison is VOC is equal to if you compare these two, ZOC into ISC, ISC is equal to VOC by ZOC. So this is a very simple comparison from Thevenin's to Norton's. Actually, in one way to say, this is like voltage source is converted into current source. The only difference is source transformation, we really talk about sources, whereas here we talk about voltage and current. They are not the sources, they are the equivalent sources. So, whether it is equivalent source or the source, they have the same conversion. Therefore, if you know Thevenin's equivalent, you can easily say you already know Norton's. So, the impedance is same, only current to voltage, voltage to current. That's the meaning. Then, the third, if you say this is an introduction here, and second point is comparison, then I am going to talk to you about one small thing. That is, the third point before I go into problems is very simple. How to calculate ZOC? That's the main idea, because that's common for both, and most of the time they are interested in impedance, particularly when you go to maximum power transfer theorem. They need to know what is the impedance in order to suit that. When the impedances are equal or the magnitude of impedances are equal, maximum power is transferred. That's why ZOC became more important than VOC and ISC. Therefore, ZOC is required for Thevenin's, ZOC is required for Norton's, ZOC is required for even maximum power. Therefore, what are the different ways to do? The first thing is, if a circuit has only independent sources, what to do? That is very simple. Short circuit voltage source, open circuit current source. And then what is R equivalent or Z equivalent available? That's called ZOC. When is this valid? This is valid only when only independent sources. For example, if we have independent and dependent, suppose you have independent and dependent sources, what do you do there? Here you cannot do this job. Short circuit voltage source, voltage circuits, you can't do. Only thing you have to do is, why we cannot do? Suppose there is a dependent voltage source, how can you do that? If you do this way, if you short circuit a dependent source, you are shorting not this, something else, because this is depending on something. That's why the best way is ZOC is VOC by ISC. What does it mean? It means very simply, you calculate VThevenin's as well I Norton's. In other words, we have a very important concept. Without Thevenin's and Norton's, you will never get ZOC. That's why whenever there is a dependent source and independent source together, this is the approach. The third and the last approach is only dependent. What to do? If you have only dependent source, the best thing you can do is, you have to assume VOC is equal to 1 volt, then ZOC is equal to VOC by ISC, 1 by ISC. That's it. Therefore, when you talk about calculating the ZOC, there are three approaches: only independent, independent and dependent, and finally only dependent. So this is the idea about 3 points to remember before I take you along. So let's go into problems with this background. We have done so far in the previous lecture 10 problems. That's why now we are starting from 11. The question goes like this: calculate R Thevenin's, and this is 3 ohms, 6 ohms is given, current I is entering, and that is depending and dependent source is created here. The options are 1 ohm, 2 ohm, 3 ohms, 4 ohms. The first question comes to a student is, what is approach? There are 3 approaches for orthogonals as I discussed now, which this comes under only dependent sources. That's why I am telling you a precaution. Don't follow any textbook which deals only with dependent sources. Whoever prescribes it, whatever strong recommendations are there, don't follow, because every problem will have dependent sources. So, let us take this problem and see the solution. The solution for this problem is, the question is given like this. This is a resistor, this is dependent source, okay, and you have a resistor here. This is 3 ohms here, 6 ohms here, okay. This is current I. So he said 3I. Okay. Now, what to do? As I have mentioned just in the beginning, please take 1 volt here. That's called let VOC is equal to 1 volt. So if you assume VOC across these terminals here, then apply. So this voltage is 1 volt, means this voltage automatically become 1. So that means what? Please understand this. Apply KCL over here. Minus I 1 by 6 1 minus 3I by 3 is equal to 0. Once again, minus I because entering, 1 by 6 because this is ground potential, 1 minus 3I by 3 is equal to 0. There, the only unknown is I. So solve for this I, and we can take LCM here. Say for example, you can call this as minus 6I plus 1, because 2 comes here, 2 minus 6I is equal to 0. If I take LCM. So this becomes 12I is equal to 3. Therefore, I is equal to 3 by 12. 3 by 12 means what? 1 by 4. So this can as well be treated as short circuit current. Why? Because if we short this, how much current flows? That is same. Therefore, as I told you, ZOC is equal to VOC by ISC. VOC by IS. VOC is how much? We have let as 1, then IS is 1 by 4, this is 4 ohms. That's a very simple solution as it is given. The option is D, 4 ohms. Your option in the solution is D. Okay. Now, what is the equivalent circuit? Suppose they ask for equivalent circuit. Some people are drawing like this. They are saying this is a VOC, ZOC. They thought this is the equivalent. Some people thought Norton's means this way. Because our normal expression, normal style we follow. This is, then what is VOC? Then what is ISC? This is again same ZOC. So for them, ISC is equal to VOC by ZOC. But actually all are wrong. Both are wrong. Because when there is no independent source, how come the source come? So please remember, when the circuit is purely dependent, you will never get VOC or ZOC. So this is not correct. This is not correct. The best one is this. Just 4 ohms. That itself is Thevenin's and that itself is Norton's. This came so many times in competitive exams. In fact, our question is only to calculate impedance, but suppose they ask extra like this, don't draw these things, this is the answer. That is the solution for this problem, an extended idea of this problem. Okay. What is the value of Norton's current? IN means current Norton's, is given in GATE 2009 2M Look at this circuit. In the circuit given, we have options given here. Again I am telling, the circuit given is having what you call, what is the value of Norton's? This problem also have two things, independent source, good. Then we have a resistor, right. Then we have another resistor here, dependent source here, okay. And then another resistor, okay. Look at this, this is 5 volts, resistor is 2 kilo ohms, another one is 2 kilo ohms. The source that he gave was 3 VAB, and then another resistor is 1 kilo. Now the immediate question comes to a student is, whenever you have a dependent source, you should always ask a question, where is it depending on? So the examiner gave, this is where it is depending on. So dependent source meaning is that. Then very interestingly, this becomes VAB, okay. This is another special variety of problem, because this is depending on this. Suppose if this is shorted, this is get shorted, because as I told you, whenever there is a, now I am going to the solution for that problem. The first thing we have to, as I told you, whenever there is a dependent source, what is ZOC? VOC by ISC. In other words to say, V Thevenin's by I Norton's, okay. But sometimes by short circuiting that, if that get avoided, that get lost, you will be very happy. But anyway, follow the standard procedure. So the first thing that I need to talk to you is how to get this, because the question is ISC only, we don't need to go for Thevenin's also. VOC not required, just ISC, because when you calculate ISC, what is ISC? So you need to see two things are required if it is impedance, but if it is asking simply volt current, you can finish it off. Let me draw the equivalent. For example, he is asking short circuit, so this is short circuit current. When you short this, he is asking for short circuit current. So I have shorted this. Please enjoy what happens by short circuit. First of all, this will go away. Why any resistor goes away? Whenever you short, this impedance becomes high. No current can be here because most of the current is going there. This is becoming open circuit. There is another understanding. Some people say this is open circuit, that's why no current here. Most of the current is going. Otherwise, zero resistance parallel zero resistance becomes 0. That is also short. So ultimately, either way, this resistance will not come. That's a good thing. Secondly, when you short circuit, what is voltage between these two? 0. When the voltage is 0, what will happen to this? Automatically, when VAB is 0, 3AB becomes 0. What a nice thing. In the sense to say, when you say this one, 0 volt, voltage source has become 0. When the voltage source has become 0, okay, I mean this value becomes 0, therefore current source is becoming 0. Current source becoming 0 means what? This get again open circuit. Okay. When this gets open circuit, then what is the current in this branch? Now I will draw the equivalent. For example, this is the open circuit. This is the current. Okay. Now, in this option, automatically answer is 0. That is one option that we should have. Then, suppose the same voltage source is here. Instead of current source, suppose they put it as a voltage source. Okay. Same thing is get shorted. This goes. VAB is 0. ISC is here. 3AB also 0. When a voltage source is 0 means short circuit. Then I will draw the equivalent for you. So, this is the voltage source. This is shorted, okay, and this is shorted again. So, please remember this is short circuit, okay. And when this is short circuit, because of this short, this became 0, because of this became 0, this also go. So, this also open circuit. Now, what is the final answer? This is 5 volts, this is 2 kilo. When you say 5 volts and 2 kilo, what will be the answer that you can achieve? The answer is basically 5 volts by 2 kilo ohms. How much? 2.5 milliamperes. That's the option. Calculate R Thevenin's. Get 2000, 2 marks. See, it is given for 2 marks because dependent source is there, no independent source. Solution, come on. Say KCL we apply, minus I plus 1 by 4, 1 minus 2I by 2 is equal to, let me take LCM, minus 4I plus 1 plus 2 minus 2 into 2, 4I is equal to 0. This of course goes, 8I is equal to 3, I is equal to 3 by 8. Therefore, ZOC is equal to VOC by ISC, 1 by 3 by 8 is 8 by 3. So, the option is B. In the circuit shown, what is the value of RL for maximum power transfer to the load? This GATE 2009, 2 marks given for EEE. See, whenever we talk about a problem on maximum power transfer theorem, we generally think it belongs to maximum power transfer theorem, but it actually belongs to Thevenin's theorem, because we need to get the impedance across the load. So, let me take this circuit, though it is a little bigger. Voltage source is given 100 volts, then we have 4 ohms here, another 4 ohms here. This is the source. Then he has given a voltage source dependent like here, and then he has given all 4. This is RL, and this is 4 ohms, 4 ohms, 4 ohms. The dependent source is given as minus plus Vx. So, whenever a dependent source is given, you should always ask where it is depending on. So, this is minus plus Vx. So, this voltage is developing this, that is a meaning. Now, because there is a dependent source, the best way to calculate ZOC is VOC by ISC. Whenever there is a dependent source, don't go for short circuit, open circuit, concept, go for this way. Don't try to short circuit this and short circuit this. Short circuit independent source may be allowed, but this cannot be allowed. That's why we don't do anything. Why? If you short this, this is shorted. That's why dependent source you should never short it. That's why best way to calculate is this. So we need to calculate two things separately. The first target task for us is to calculate VOC. If you are calculating VOC, you can just say like this, as if that is open. Now the voltage you have to calculate between these two terminals. So what is the voltage between these two terminals? It's as simple. If you apply KVL, 100 minus to plus, you say plus Vx, call some current here, I. Okay. So minus 4 into I minus VOC 0. That's what we need. From this you can calculate what VOC is. But for that reason you need to know what is I, what is Vx, where Vx is defined as, can you just think over what is the meaning of Vx? This is going, current is going in this direction, so this is minus 4I. Please substitute there. Vx is minus 4 Vi. Then the total source, the total equation will come in terms of I. So bring everything in terms of I. So that means 100 plus minus, in the meaning of, in the place of Vx you can say 4I. You can simply say minus 4I minus Vs. That means VOC is equal to, that it goes that side, 100 minus 8I. This is VOC. Think over. So if only you calculate I, the answer is ready. How to calculate I? Again go for KVL in this equation. Let me give another KVL. Another KVL for this loop is plus Vx, good, minus 4I, good, minus 4I minus Vx is 0. Once again, plus Vx minus 4I minus 4I minus Vx. You can just cancel it. If you cancel this, you have 4I is equal to 0. In the process, I becomes 0. If I becomes 0, what should be VOC? 100 volts as such. That's one option there. Then we have to calculate ISC there. When you calculate ISC, when you short this, if the total figure will change. Now we need to calculate this way, ISC. That means this terminal is becoming short circuit. Then we have to apply again what is the current flowing in this. For example, if this is I, this is ISC. Instead of doing the separate. So let me draw this circuit separately. This way, 4 ohms, 4 ohms, 4 ohms, minus plus Vx, 100, and here minus plus Vx. So this can be called as ISC. Calculate. If you calculate ISC and then substitute whatever the ISC comes, you can apply. Suppose this is 0 volts, this is 100 volts. Okay, So, how much is KCL you can apply? There is a direct voltage here 100. If you apply the how much current is entering, how much current is leaving, apply this way. So, you can start from here this loop directly, plus Vx minus 4i minus Vx is equal to 0. Or you can say the voltage between these two terminals is 100. If you apply from here, 100 is equal to 4 plus 4, 8i. 100 here, 8i here, plus ISC is equal to 0. So, we have to solve for I here and then substitute here and solve for ISC. Then for ZOC is equal to VOC by ISC. So, what is the voltage that we get here? If you solve all this, you will be getting 8 by 3 ohms. Whatever that you got there, whatever you get here, if you substitute, 8 by 3 will come. That is the option. Right. Maximum power that can be transferred to the load RL is, we need to calculate the power. So far, we have been calculating the impedance for maximum power. If the circuit is big, they can ask you only for impedance. But now you see the circuit is small, therefore, they are directly asking the power involved. So, let me take the circuit from the problem. This is here, this is here, this is 100 ohms, this is 10 ohms, this is RL. The first thing we have to do is, what is the impedance required for maximum power? What is impedance there? If we short circuit this like Thevenin's, it is directly 100 ohms. Therefore, for maximum power transfer, the condition is 100 plus yes. So, power is equal to I square RL. That is it. Power delivered to the load. So, what is I? I is equal to 10 by 100 plus 100, that is 10 by 200, that is 10 by 20. Good. Now, what is power? Power is 1 by 20 whole square into, this should be 100 ohms. Why? When these two are equal, there comes maximum power. That means go for multiplying with RL. RL is 100. So, 1 by 400 into 100. So, answer is 1 by 4, that is 0.25. The option is C. So, for this option is C. So, simple. That is the problem. If the impedance ZL is connected across a voltage source V with source impedance ZS, then the maximum power transfer to the load is, what is the option? What exactly he is saying is, suppose he says, let us understand the problem. He said like this, Vs is voltage source, Zs is impedance, then comes what? This is ZL. ZL. Okay. Now, look at this point. What is the meaning? They should be complex conjugate. So, please understand, for maximum power transfer, okay, if we say ZL is equal to 0, ZL will come as ZX complex conjugate. This is called actual theorem. The corollary of the theorem is, corollary means reverse way of telling. That is, if you say this one magnitude, you have to say ZL is equal to ZS. So there are two meanings of this. If this is complex conjugate, if you take magnitude, anyway they are same. That's why normally students are only looking at this, but this is more important than that, because most of the time that doesn't work. For example, this works only when you say 0 plus j3, so 2 minus jx, then you can simply say x is equal to 3, provided these two are equal. If they are not equal, you can't say that. Or if you are simply asking for an example that is 2 minus j3, you can say. So therefore, but more, if they are different, the best thing is absolute value or the magnitude. So we are now in this problem, very simple. Source impedance, no. Complex conjugate of source impedance. That's why answer is B. This is purely, no calculation is involved here. It is concept based questions. The Thevenin's equivalent impedance between the nodes P and Q in the following circuit. This is AC circuit, but answers are given in S domain, no problem. So look at here, there is a resistor, then you have inductor, this is P and Q, then you have a capacitor, then you have a current source, then also you have a resistor, 1 ohm, 1 farad, 1 Henry, 1 ohm. In fact, he is asking simply the impedance between PQ, that is called ZOC. When you want impedance, the best way to say is, this is short circuited. Please remember, as I have been telling, when there are independent sources, you can always go for short circuit, open circuit. This you open. Now please redraw the equivalent circuit. The equivalent circuit is very simple: inductor, resistor, capacitor, resistor. This is PQ. So simple. Because these two are coming in parallel, these two are coming in series, series and series coming in parallel. So simple. Now the best way is, always remember, L becomes Ls, C becomes 1 by Cs, R retains to be R. This we should not really memorize, we should actually say this came from Laplace transform. So Laplace transform helped us to know. So if I say this, Ls means 1s, this is 1 by s and 1. That's it. So therefore, what is the ZOC or Z equivalent here? S plus 1 into 1 plus 1 by s by s plus 1 plus 1 by s plus 1. Simple. So what will happen now? This is Z1, Z2 by Z1 plus Z2. That's what it means. For example, for your clarification, I'll do like that. S is S here. S into 1 by S is 1 here. 1 is 1 here. 1 by S here. Now this is S plus 1 by S. 1 plus 1 plus 1. That is 1. Answer is 1. Therefore, option is A.